Hi guys, Dr. B here. This is topic 7.4, calculating the equilibrium constant. So the objective is to be able to calculate Kc or Kp based on experimental observations of concentrations or pressures at equilibrium. So if a system is at equilibrium, it depends on the relationship between concentrations, partial pressures of chemical species, and a constant K. In the previous lesson 7.3, we learned how to write out the Kp, Kc, Qp, Qc base if you have concentrations or pressures. You can calculate the value for these by plugging in experimental concentrations or partial pressures and coefficients from the balanced equation. So let's look at these two examples right here. We have 2 copper 2 plus lead 2 plus produces 2 copper plus and Pb4 plus in a reversible reaction. That means it goes either way, it's an equilibrium. You'll notice that when we do this, we need to have our reactants over our products. These are all aqueous, that's why we're able to do this. In the following experiment, you have these different concentrations. And you can calculate the value for the reaction quotient. QC, and then you just kind of plug in your numbers, your concentrations, make sure you square where it needs to be squared. There are no units for reaction quotients or equilibrium expressions. However, if we have pressure, we're going to use atmospheres or ATM. We're going to see why in Unit 9. So we have our gases, N2 plus 3H2 makes 2NH3. So then we create our equilibrium constant. So P, because these are pressure, these are gases. If the equilibrium constant for a reaction is 0.061 at 500 K, well, yeah, let's say that's what it is. So then we have a partial pressure given and H2. What is a partial pressure of NH3? We can actually rearrange to solve for just what we're looking for, which we're going to do in a second. What is the value of the reaction quotient for the following system? We have four partial pressures. So what is this going to be? So our reaction quotient, since they are pressures, so we have pressure of CO2 cubed times the pressure of water vapor, to the fourth divided by the pressure of C3H8 times the pressure of O2, make that to the fifth, plug in your numbers. So I'm going to plug in these things. So 0.789 cubed plus chihuahuas plus 0.123 to the fourth. What's that? Oh, I'm doing plus. I'm sorry. These are times. I'm silly. So I do my math. I end up with 4.64 times 10 to the negative 8. A reaction to A plus B makes C plus D. And it has an equilibrium concentration of 0.0234 at 450 Kelvin. Given the following concentration, solve for C. So you have to first make sure we have the correct equation for this to get the concentration, all that type of stuff. So this is concentration, so QC equals C squared times D divided by A squared times B. So I'm going to solve for C. So that means I have to multiply both sides by the reciprocal. So QC times A squared times B over D. That equals C squared. So I'm going to take the square root of this. That's going to give me my C. So I don't know why I did like this, but it's fine. So the QC, it's given 0.0234 times 0.261 squared times 4.13, all divided by 2.91 to give me my C. I do my math, I will end up with 0.0476 molar for this answer. If this reaction was performed at lower temperature where the KEQ is lower, what will happen to the amount of all the reactants and products discussed in terms of X? So if my QEQ is decreased because it's a colder temperature, my reaction will shift to the left. So that means that it's going to look like this. So remember that this is what it looks like. It's going to go this way when I lower the QEQ. So that means my products and reactants are going to change based on X. And it's based on their concentrations as well. So for example, use a different color. Because I'm shifting it to the left towards the reactants, my reactants will increase by their correct amount of product. What does that mean? So it's going to increase by 2x, by 1x based on the coefficients, decrease by 2x, and by x. So whatever x this is, we have to talk about what's going to happen to each of these. So for example, I'm going to verbalize because I don't have space. So my reactant A will, because this is my original concentration, it will increase by 2x, whatever x is. Letter B, 4.13 molar plus x. For letter C, it's going to have 0.0476, so it will decrease by 2x. Letter D, or whatever B, will decrease by x, so 2.91 molar minus x. All right, gentlemen, so you have any questions, please let me know. Thanks.